So guys, let's see our next question. It's merge k sorted list. It's a hard problem in Leetcode. You are given an array k linked list and each linked list is sorted in ascending order. We have to merge all the linked list into one sorted linked list and return it. Let's see this test case. 1 4 5 1 3 4 2 6. It's like 1 4 5 1 3 and 4 and 2 and 6. It's like this. So we have to merge this. On merging in sort, these are sorted, already sorted, and so we have to make a result like we have to merge this list and make it sorted. So the result will be like 1 and 2 and 3, then 4, then 4, then 5, and then 6. So this will be our final answer. So how we have to do this? What's the intuition? So let's see the intuition. Okay. These are basically the minimum. This is the minimum elements on the first because the linked list are sorted. So we have to choose the minimum from these first. Okay, like these all are the minimum. So we have to choose minimum of these. That will be our first element, and then go next. So what's the intuition? It's the intuition is min heap. We will use a min heap. How we will use? Let's see. Like in a min heap, we will store the first node of each linked list, like 1, then 1, and then 2. This is our min heap first, and we will create a dummy node which will be initialized to -1. So it is a basic linked list concept, and there is a pointer temp on this node. Okay, and first we have to make a min heap and store all the first node of each linked list in this min heap. And on the popping of the top element means root element, that will be minimum element, and add it to a dummy node. So it will be like this, and move our temp to this. Okay, move. Okay, and the element we have popped in that linked list, we have to make a pointer node onto it. Like we have to make a pointer node here. Okay, we will associate with node. Now we have to, after popping this, we have to push node to next element, and after pushing node to next element, this will heapify and it will become like 1 and 2 and 4. Okay, it will become like this. Now after popping this and move the node to next, no, our node is initially here, and we have to pop this and add to this, and our node will come to here. Okay, now we have to push the next element here. This will be 3 and it will heapify and become like 2, 3 and 4. Now we have to repeat the same procedure. We have to pop this, add it to here, and the node will come to here. Okay, now we have to push the next element 6. Okay, and it will heapify itself. So 3 and 4 and 6. Okay, it will heapify, and we have to pop this, node will come to this, and it will be added here. Okay, so as this one, it will reach the last element, and we will get our sorted linked list. Okay, so we will now write the steps what we did. First we created a min heap. Okay, second we pushed first element of each linked list in min heap. Okay, then we will do till our min heap is empty, and what will we do? We will mark node pointer to the top element, then pop it, add to dummy node, add it to dummy node. Okay, and we will move our pointer temp, that we will see next. Okay, temp that we will see in the code part. And so after we will reach the null pointer, we will stop, and we will get our sorted linked list as the final answer. So it is basically a medium problem. It is marked hard, so it's a basic intuition problem. So let's code this. So just now first create our mini. But there is some problem, like in this mini we have to store the list node. We have to store the node data type, and in this priority queue there is a thing that it will take only integer data type, so we have to create a custom comparator for this. Okay, so this is a basic STL part. So what we do, so our comparator will look like this, and this I'm not going to tell how we will achieve this. Let me explain. If we are taking one list node A and other list node B, we will return if the value of A is greater than value of B. So it will form a mini heap after all, and it will be like this. And we have also to modify this because we are using a list node data type. So list node star comma vector of list node star comma compare. So now our mini heap is created. Now what we will do, we will process our step 2. What is the step? We will push first element of each linked list in the mini heap. Okay, so let's do this. For auto in lists, okay, and pq dot push I. But there is a case, like if our linked list is having null node, so we will not push this. So we have to return null. So we have to check if it is not null, then only we have to push this. Okay, so if is not I, if I is not equal to null pointer, then only we have to do this. So this is the case. Okay, now what's our second step? Our second step is we have did this. Second step is to create a dummy node. Okay, to create a dummy node. So we'll create a dummy node, list node star dummy is equal to new node, new list node, and we will initialize this to -1. Okay, now we are having a temp pointer. So start temp is equal to dummy. We will have to use this temp on the dummy node. Now what we will do, we will now we will now do our basic all operations, like we will take the top element and add to a dummy node and also we will just put a while loop. While is not pq.empty until our priority queue is not empty. We will do this. Okay, now we will take our top element and make it to a node star. We are having a node equal to pq.top. So and then we will pop that from the priority queue, and now we will check if our node is not equal to null. If node equal to null pointer, then we will return null pointer. Okay, we will check to prevent an error. Now we will do, like, we have to push this in dummy node, push this node in dummy node or in final linked list. So node equal to dummy temp. This will be like this, and now we will move our temp. Our temp is now updated also, and one case is remaining to push now next element of node pointer. So we will check if node next is not equal to null pointer, so we will push it in, and this is our case. And after all, we will be getting all, and we have to return the final answer, like we have to return dummy next. because dummy is the starting node -1. So we will return dummy return next. Let's run this. There is a compile error. So there are so many errors like this. Here we are using some extra brackets, so we will remove these, and it's now correct here. And we are also doing some mistake here. These are next. I don't know. This is now correct. And what's next? What's next? Now, okay, let's see. Okay, this is compare. C is capital, so we will make the C capital. Now we will run. Now this is accepted. Now we can submit this. So it's submitted. So let's wait for next question. Till then, goodbye.